Hi everyone, welcome back to the channel. Today we're going to dive into the world of binary numbers and learning how to add them. Binary numbers might seem tricky at first, but with a few simple steps, you'll be adding them like a pro. So let's get started. First, we're going to talk about what binary numbers are. So binary numbers are made up of only two digits, 0 and 1. Computers use binary numbers to process data because they can easily represent the on and off states of a computer's switches. Today, we'll learn how to recognize if a binary number is odd or even, understand what happens when we add an extra zero to a binary number, and how to add two binary numbers together. To start, let's convert numbers 1 to 10 into binary. For example, the number 1 in binary is 1. The number 2 in binary is 1, 0. The number 3 in binary is 1, 1. The number 4 in binary is 1, 0, 0. And effectively, all we're saying is we want one lot of 4, no 2s, and no 1s. And we can see that using the orange numbers on the top. The number 5 in binary will then be 1, 0, 1, and so on and so forth. Now, this helps us understand the basics of binary. Now, how can we tell if a binary number is odd or even? It's actually quite simple. Just look at the rightmost bit. If it's a 1, the number is odd. If it's a 0, the number is even. Let's have a look at some examples. Here are some examples of odd and even binary numbers. We can see the first example where we have 0, 1, 0, 0, 0, 1, 1. This ends in an odd number. So, sorry, this ends it with a 1, which will make it an odd number. The second set of digits that we have, 0, 1, 1, 1, 1, 1, 0. It ends with a 0, so it's an even number. And the last example that we have ends with a 1, so this will be an odd number. Next, let's see what happens when we add an extra 0 to a binary number. Now, before we get to this, in the decimal number system, adding a 0 multiplies the number by 10. For example, if we take the number 5, then we add a 0 at the end of it, it becomes 50. So 5 multiplied by 10 is 50. In binary, however, adding a 0 at the end will double the number. So 1011 will become 1011 and then the 0. So initially 1011 would equal to 11 in decimal, but because we added a 0 to the binary digits at the end and made it 10110, it now became the number 22 in decimal. Try adding a 0 to 0101. It becomes 01010. So initially it was 5 in decimal, but because we added the extra 0 at the end, it has now become a 10. So we can see that adding an extra 0 will double the number in binary. And we can see some examples of this on the screen right now. Okay, so what happens when we add a 0 to the left of a binary number? It doesn't change the value of the number. For example, 0101 is the same as 101. Let's review how to add decimal numbers then. We add numbers from right to left. If the sum exceeds 9, so it goes beyond 9, we carry over to the next column. For example, let's add 14 and 17. First, we add the units. 4 plus 7, which will equal 11. We write down 1 and carry 1 over to the left. Next, we add the tens. 1 plus 1, and then the 1 that we carried over, so this will now equal 3. So 14 plus 17 equals 31. Now let's learn how to add binary numbers. We'll use the same right to left method. Let's add 1011 and 1010. First, add the rightmost bits. 1 plus 0 equals 1. Next, add the second bits. 1 plus 1 would equal 0, but we're going to carry 1 over to the left. Then add the third bits. 0 plus 0 plus 1 that we carried over from before would actually equal 1. Finally, add the leftmost bit. 1 plus 1, which would equal 0, and we would carry 1 over to the next column. So 1011 plus 1010 would equal 10101. Here are the rules for binary addition then. Zero plus 0 would equal 0. 0 plus 1 would equal 1. 1 plus 0 would equal 1. 1 plus 1 would equal 0 in binary, but we would carry 1 over. In the instance or in the case where you are adding 3 ones, so 1 plus 1 plus 1, you would write down 1, but you would still carry another 1 over to the next column. If we have a look at the example of what we have just below, I've color coded this to just make it a little bit easier for you to understand. So these two binary digits are actually we're going to be using the rules that we've just described above. So first, we're going to add the rightmost bits. So 1 plus 0 equals 1. And these are the numbers that have been colored in blue. So 1 plus 0 equals 1. Next, we're going to add the second bits. Now these bits are the ones colored in pink. So 1 plus 1 equals 0, but we're going to carry 1 over onto the left column. Then we're going to add the third bits. The third bits have been colored in green. So 0 plus 0 would normally equal 0, but because we've got the 1 carried over from the previous bit, we've got 1 from the pink bits. So we're going to add that. So it's going to be 0 plus 0 plus 1 would equals 1. Finally, you're going to add the leftmost bits. So 1 plus 1 equals 0. So again, I've highlighted this in pink on the left. 1 plus 1 equals 0, but we're going to carry this over onto the next column. Now we can see on the leftmost column, the one that's there isn't anything else that we're adding there. So this is colored in sort of a pinkish red color. And it's just the one on its own. So we're just gonna pop this right at the bottom. So our answer to 1011 plus 1010 would equal 10101. Lastly, let's talk about storing large numbers. A group of 4 bytes is called a word. In a 32-bit computer, a word can hold a maximum integer of 2,147,483,647. So in an 8-byte system, the largest integer is 2 to the power of 64 minus 1, which is a very, very large number. Well, that's it for today's lesson on binary addition. I hope you found it helpful and fun. Don't forget to like, subscribe, and hit the bell icon for more educational videos. If it helps, you might want to go over this video again, just to make sure that you've understood everything. And I know practicing some of the binary addition is the best way to make sure you remember it for assessments or just generally for your own learning. See you next time. Have a good day. Bye-bye.